So 3.1 is exponential function. All right, and I want to remind you that an exponential function is a function. What? Yes? Okay, anyway, exponential function is a function with an unknown. This is my favorite class of the day.
All right.
Okay. There's an unknown. Hey. So as I was saying, an exponential function is a function with only an unknown or a variable in the exponent.
Oh, wait.
So usually it looks like this. F of x equals a times b to the x. The unknown is right up there. This first letter, a, is the initial value. Or sometimes we consider it the y-intercept is the same thing, the initial value. The b is the base. And if b is greater than 1, this is growth. And if b is between 0 and 1, we call this a decay. Do you guys remember doing these? Okay, good. Good call. All right. Oh, goodness. We have lots and lots we get to talk about that, huh? I am. Yeah. Thank you so much, Tyler. All right, so the parent function of an exponential function is just y equals b to the x, okay? And if b, that's not very straight, if b is greater than 1, it's a growth, and it goes this way. And if b is between 0 and 1, it starts big and it decays and gets smaller and smaller. Those are our two options. This is the growth, and this is decay. Each of these have two very important points. Just like when we talked about graphing launch yesterday, it had 2 points. Exponentials have 2 points. This one, which is the point 0, 1, and there's one more point over here, which is going to be 1, and then whatever the base is. Same thing here. This point is 0, 1. And then there's a point here, which is 1 and whatever the base is. There are two options. All right. Any questions so far? Letting know right now. All right. So first let's talk about, if you look at both of these, what would be the domain for each one? You're close. Yes, it would. Negative infinity to infinity for both of them. Because it's the x value. For the range then would be from 0 to infinity. Because it comes close to 0 but never touches it. This would be bounded below. Remembered all that boundedness we talked about before? Bounded below. It has a horizontal asymptote at y equals 0. And there is no vertical asymptote. Each of these have two end behaviors. We got to make sure we talk about those. So, end behavior for this one, as it is going as x limit as x approaches negative infinity. This is getting closer and closer to 0. And on this side, the limit as x approaches positive infinity. That arrow's going higher and higher, so this is infinity. This one is just the opposite of that. This time, the limit as x goes to negative infinity, or to the left, it goes to infinity. And on this side, the limit as x goes to positive infinity, it approaches 0. So that's the basics of what we're doing. We're going to jump into examples that are going to be similar to what you're going to see in the homework today. Okay? Okay. Example number 1. I just need to know, is it an exponential function? And if it is an exponential function, I need you to state the initial value. So I'm going to shortcut that as IV, and the base. So again, remember that if I have y equals a times b to the x, the x has to be in the exponent. This is the initial value. This, of course, is the base. All right? So we have y equals 4 to the x. Is that exponential? It is, because there's x in the exponent, exactly. So you say yes, and you say IV equals, and what is the initial value? What's in front of the 4? There's always some 1, yes, excellent. And then your base equals 4. So if I have y equals 3 times 2 to the x. Very good. IV does equal 3. The base equals 2. All right, but you're going to see one that looks like this. Y equals x to the 4th. Is that an exponential function? No, good. Nope. So yeah, your first 6 in your homework today, well no, not 6, 1 through 5, 2 through 6, because you're doing even, my bad. 2 through 6 are just like this. So I'll put over here numbers 2 through 6. Okay? Seem pretty easy? All right, good. So far, it all is easy today. All right, example number 2. I want you to compute the exact value of the function you're going to love this part, without using a calculator. You guys can handle this. So if I give you f of x equals, I don't know, 3 times 5 to the x, and I tell you x equals 0. I just want you to plug 0 in for x. So I have 3 times 5 to the 0. Well, what is 5 to the 0? So anything raised to 0 power is what? Something. That's true. Anything at all raised to 0 power? Anything raised to 0 power. Doesn't matter what it is, always equals 1. Yes, thank you. And then 3 times 1 is 3. Okay? So you have a couple of these where you just have to plug the x value in and evaluate it. Okay? Do you guys need another one of these? Okay. All right, just checking. All right. Good. I'm glad. Example 3. There we go. Example number 3. I want you to determine. No. a formula for the exponential function, and I'm going to give you a table. You're going to get a table in your homework anyway. So if I have x and I have f of x, say on this side I have -2, -1, 0, 1, and 2. And on this side we have my dog saying hello. 6, 3, 3 over 2, 3 over 4, and 3 over 8. Okay. So remember, exponential functions look like this. So really we're looking for A and B. Now you can do one of two things. You can plug this into list 1 and list 2. Go back into stat, over to calculate, and down to exponential reg. You can do that, okay? But you guys know how to do. The other option is, if I have y equals, this A is your initial value. But if you look over here in your table, your initial value is whatever is always across from 0. So we have 3 halves, goes right there, times by. Your B is whatever it is that you're multiplying by every single time. So what am I multiplying by to get from 6 to 3? Half, very good. So we just have a half raised to the x. You can either write it with a dot in the middle, or we can put parentheses around the base. That's okay too. All right. All right, so that takes us through question number 12. You guys are doing great. Example number 4. All right, we're again going to determine the formula for the graph. Writing sloppy, sorry guys. Let's say I have this growth that looks like this. We have a dot right here at the point 0, 3. Then we have another dot up here at 2, 6. All right, so again, if we're doing exponential function, it's y equals a times b to the x. Again, we're finding a and b. Well, again, we already have a, which is right here. We have y equals 3 times b to the x. So now they give you the other point so that you can plug in x and y and solve for b. We want to plug in 2, 6 and solve for b. Okay? So we have our y value is 6 equals 3 times b to the second power. To solve this, we start by dividing by 3 to both sides. We get 2 equals b squared. And now how do I solve it? Yeah, so our b just equals the square root of 2. Then you go back up here and plug it in. So our final answer would be y equals 3 times the square root of 2 to the x. Doesn't seem too bad, right? Good. Good, good, good. This works on your algebra a little bit of getting how plugging it in and moving these around. Okay, last section. Example number 5. And I shouldn't have to teach it all because you guys learned it so well in the first place. We have describe how to translate. You're supposed to be writing your notes, Goofy. All right, so in the next section, which is problem 16 through 24, I'm going to ask you to describe how to translate from f of x to g of x, and that's going to tell you to sketch. Well, I'm going to tell you, you don't need to do this. You do great, but you don't have to. Because all of us are going to grab a graphing calculator anyway and just graph it. right? When in doubt, graph it out. So are we ever going to really need to sketch anymore? No. Good. So if f of x is 0.5 to the x and g of x is 3 times 0.5 to the x plus 4. I just want you to describe the transformation. So what does the 3 do here? Yeah, we get a stretch. 3. And of course, everything else the same except plus 4 at the end. What's that do? A 4, absolutely. One more and I'm done. Yeah. I don't know. They're on my screen too, and I don't know where they came from. Yeah, I don't know. I have no idea. They all of a sudden just showed up, and they don't erase. Okay. I don't know what they are. Well, I kind of, do you want me to be honest? I figured Tyler did something. No, honestly, that's what I thought. So I was just going with it. I don't know. I'm sorry. All right, here's my last one. F of x equals 3 to the x and g of x equals -2. Mr. Shoemaker, can I help you?
Nope.
All right. Hey, guys, so how do we get from F to G? What's this do? Oh, good. So we have a flip. We have a stretch of 2. Up here with x. Oh, we have down 5. What's this up here with x do? Good. Last one. Awesome. See how easy that was?